Hi everyone, I'm Anthony Lin. I'm the OpenShift specialist covering Red Hat ASEAN.
Hi everyone, I'm Zhang Jing, automation consultant working in Singapore consultant team.
In today's topic, we are going to look at OpenShift Network Observability, in particular around the area of DDoS attack and analysis with AI models.
This DDoS attack operation, the attacker create malicious traffic. He make the network overloading that cause target server service disruption. This intelligence detect the network security analyzer. All the primary object is accurately identify, sustain malicious activity. To achieve this, all analyze leverage a combination of parallel process and textual analysis to rapidly evaluate network data and isolate real attack. The AI power analysis leverage AI for the sophisticated threat pattern, recognize as SYN, flooding, DDoS, port scanning, and so on. Parallel process, analyze, target, capture the file rapidly by using concurrent worker, reduce analyze time. So the consecutively chunk analysis to reduce false positive alert from the isolated suspicious package, the system requires a 3 consecutive malicious chunk. Each chunk is 100,000 token. Could classify the event as a sustained attack.
Thanks, Jing. So in this demo, we are going to leverage on a demo application called the To-Do app. The To-Do app is a simple application that is used to add tasks, remove tasks from the list, for instance. It is a stateless application running as a single pod, and it is connected to an external Postgres SQL VM. So the traffic flow for the demo environment will look similar to this. We have traffic flowing through from the external load balancer, right, towards the router, the ingress router itself inside OpenShift, which then flows onto the worker node, to the application, to the egress, and eventually towards the external database that is outside of OpenShift. So when under a DDoS attack, what we will see from a network topology view from the network observability operator will be something along the line where we see high number of drops between the ingress and the stateless container. We will also be able to look at things like the network flow from the network observability operator, as well as information around the traffic overview, such as how much traffic is flowing through. Eventually, what we will do is to leverage on the network observability CLI to perform a Wireshark trace on the traffic that is flowing through the environment itself. It will look similar to what you see on the screen itself when we finish doing the packet capture. With the TCP traces that has been collected, the PCAP file can then be analyzed with an AI model to perform things like TCP dump analysis, and after which it will be able to tell us what kind of issues or attack we may be facing in the network environment. Do note that this is just a DDoS attack that we are simulating. We can always use the same way to detect other kind of threats that is going on inside the environment itself. And next, we will move on to the actual demo where we will walk you through all those different things that we were talking about, including how we are able to detect, capture the TCP dump, as well as leveraging on AI to do the analysis. Hi, in this demo, we are going to look at how we are able to leverage on the network observability operator to try and figure out where the packet is dropping, and to be able to do things like TCP dump to capture the packets that is flowing inside the cluster itself. So what we are going to simulate is a situation whereby we have a DDoS attack coming from different servers, and using the network observability operator, we can see that there are issues going on inside the environment, and we can trigger off TCP dump to pick up information that can be used for further analysis. So from this view itself, we can see that we have master nodes, we have infrastructure nodes that is hosting the ingress component where the traffic is coming into the cluster. And we also have a couple of worker nodes that is being deployed inside this environment. Looking at the network observability operator, we can see that it has been deployed and is in a ready state over here. The applications that we have is a to-do application. We can
just key in some information over here to generate some traffic. And from here, we can see the network traffic graph of this particular application. If I were to do a refresh, I can see that the traffic is coming in from ingress infra 0, as mentioned over here, towards the container. I have an external Postgres database that is being used by this stateless workload that is running inside the OpenShift cluster itself. If we look at the traffic flow, we can also see where the traffic is flowing across the environment itself and whether there's any drop that is happening over here. There are all these different things that is being shown in this case, where the container and the infrastructure nodes have traffic that flows across each other. There's also the Postgres database that is mentioned here. If I were to look at some of the columns that I can manage, I could actually specify things like the destination subnet labels. We can add things like the destination IP and port, source IP and port. We can also include other information such as the packets, collection latency. All these are the information that we can either add or remove, or even things like network events, and we can save, right? And then we get to see more information coming in over here. We can see which namespace it is, and those are some of the information that we can refresh. Right, we can look at the number of flows that is being allowed. We can do filtering as needed. We can specify the flow of direction from the environment itself. In this case, we just want to see traffic flowing in and out of this particular namespace. We already have set up the filter. That's why it says filter already exists. Those are things that is present. These are all informations that we are able to get over here. Based on this, what we are going to simulate next is really a form of very simple DDoS attack. I'm using slow HTTP test to try to attack by generating traffic towards the endpoint of the application. And I'm going to do the same thing over here as well. So what will happen in this case is it's going to start to generate traffic, and it will look like it is a DDoS attack towards the end target. So what happens then is we will start to expect drops that is going to happen within the environment. If I were to start to filter traffic that contains drop, and you can start to see packets that is dropping. So this is actually a symptom that something is going on within the environment itself. So one of the things that we can do in this case is to actually turn on things like the TCP dump, leveraging on the network observability CLI. We are targeting the ingress node itself on port 443. We leverage on the node selector labels where it finds that it is going to start tracing the infra 0 and infra 1. So from a OpenShift perspective, you will start to see this network observability CLI namespace that has been created with all the containers that will then be spun up in order to act as probes that will help to capture the packet and traffic flow that is going on within the environment itself. So what we can see is the containers will get spun up on infrastructure node 0 over here, as well as node 1 over here. And then the collector will start to get created as well. So now it is running. If we were to go back to the screen, we can start to see TCP traces collecting across this particular node, targeting specific traffic that is flowing through port 443 via the ingress nodes. If I were to do Ctrl+C, I can then capture the information as a TCP dump. And you can see that it auto cleans up the namespace itself with all the containers that was previously running. Everything will get deleted and terminated after we stop this service. So it cleans up itself, which is actually good for us when it comes to being able to capture and clean up resources as needed. So one of the added benefits, of course, in this case is that we are able to collect information and traces in parallel without having to log into individual nodes itself and running TCP dump across all these different nodes. So it helps us to be able to do faster troubleshooting and correlation as needed. So of course, one of those things that can happen after this is we can send the packet traces or further analysis by the networking team, for instance. So we could actually see that the packet capture is going to be shown over here as what we can see. This will be the PCAP. If we were to open up one of such files, it will look something like this. You can see over here that this is actually the container IP. We will be able to see information relating to where the traffic is flowing, whether there are any things like retransmission that is happening. These are all the container IP addresses that is flowing through. This is the thing that you will get once you open up this particular file using Wireshark, for instance. Other things that can happen, of course, is that we can leverage on AI to help us to analyze all this packet that is being captured. Obviously, DDoS attack is a rather easy way of doing a simulation and capturing information. What can happen, of course, is that we can use it to look at other anomalies that is going on within the environment and try to do further analysis. So what I've just demoed is really a way in which we can leverage on the network observability CLI to collect information and traces, and how we can actually leverage on the network observability capabilities inside OpenShift to further analyze things and to look at the health status of the cluster itself. As mentioned earlier, one of the ways in which we can analyze the TCP dump that was captured is to make use of AI. In this case, we have downloaded the PCAP file and has uploaded them to a server that is able to make use of frontier models such as DeepSeek to perform further analysis on the packet traces. We will call on the program itself and pass in the PCAP file for further analysis. So what we are doing over here is to cut them into chunks of 100,000 tokens so that we can perform parallel processing and to be able to get insights from the packet traces that was captured. In this case, we are using DeepSeek to help us with the analysis. So we can see that the Wireshark traces was captured and chunked into 23 different parts. The logic that we are using over here is to check if there are any signs of DDoS attack. And if we see at least 3 consecutive chunks that contains signatures that corresponds to a DOS attack, we will flag it as a potential DDoS attack that has happened on the applications. So as can be seen from here, we are able to see the IP address that is going towards the target applications. And because of the information that we have over here, we can then perform further analysis and inform the security team to further identify what is happening over here.
We hope you have enjoyed the demo, right, that Jing and myself have created. We'll see you guys next time. Thank you.